Okay, good morning, everybody. So we'll go ahead and get started here. So good morning and welcome to our Consul Service Mesh Day. Very excited to have everybody here. Today, we're going to cover all things service mesh. So we're going to be starting with like, how do you get started? We're going to be talking about some more advanced use cases, and we really have an awesome lineup of speakers. First, I just wanted to cover a couple of logistics items. So first of all, this session is being recorded. We will be posting the recording on our site after post-processing. Usually takes us about a week or so, and we'll be sending a link out to everybody who registered today. During the sessions, feel free to drop in your questions. There's a Q&A box down at the bottom. We'll be answering them as part of a live Q&A panel at the end, except for our first session. I'll be explaining that in a second. For our first speaker, I'm very excited. We have Pierre Sujet from Criteo. He's going to walk us through how the Criteo team has implemented their service mesh and kind of what their path and what their journey is going to be. And with that, I'm going to turn it over to Pierre, and we'll take some questions for him at the end. So Pierre, I'll go ahead and turn it over to you.
Hello, everybody. So today I'm gonna. I'm Pierre Souchet. So I'm working for Criteo, and I'm leading a team responsible for the discovery of services within the company. I'm also working a lot on Consul, improving it with performance and security patches. And I also wrote a few tools around Consul, Consul Template RB, and HA Proxy Consul Connect. We will see it a bit later. So today, I like to, so here is the menu. We'll start a bit with seeing how Criteo started doing service mesh and why we did it. Then we will see how we use Consul Connect for now, and how we plan to use it in the future, and what we did to make it work. So Criteo is a company displaying ads on the internet. So it's a very, very large infrastructure, around 40,000 servers, with several data centers, with many kind of services. We've got around 4,000 kind of different services, and many, many instances, around 250,000 different instances of those services. And we are being hit all the day by many, many requests per second. And we'll see that it's very, very important for the business to be both very fast and being able to handle a large number of requests per second. So what I propose is I'm gonna come back a bit in time, in 2010. At that time, Criteo was displaying banners with monolith applications. At that time, it was already huge. We had already lots of servers, and we were. What is critical for Criteo is having a very, very small latency. We are participating to auctions on the internet to know who is going to display an ad. So it's really, really important to be able to handle large volume of requests with very, very small latency. So at that time, we reached a point where our big monolith application were not able to evolve anymore. The data set of the data handled by this application was too huge for a single machine. The code was too large. It was too slow to upgrade, and we had several of those applications sharing the same information. So at that time, we wanted to move towards microservices. So it's not microservices like a very small feature or something like that. It was a huge feature, but just huge applications doing just one thing, such as guessing whether we should display the banner for the user or not, for instance. So we started doing microservices, and as I told you, we are supposed to answer to those requests very, very fast. So it was directly in the design measure requests to be able to be very fast. So we had two solutions to address those services. Either we should go so our application was supposed to call other microservices, and we've got, at that time, we had two kind of ways doing it. Either by choosing a kind of load balancer architecture. So basically, the application is gonna call a load balancer, and the load balancer will forward the call to the service itself. Or do service mesh. So service mesh is simply your application is contacting directly the microservices it is interacting with. So we had those two opportunities. And just to give you some insight about what kind of load we have to handle, this is a real graph of the bandwidth on one server of one of those microservices. As you can see, it handles more than 2 gigabytes of data on the interface. So it's actually several instances. So it's very, it needs lots of bandwidth just to compute the data. And the east-west traffic within our data center must handle those cases. So we had two things. We had a huge bandwidth between those microservices, a really important business need for very low latency. And at that time, the architect of within the company computed that we would need around 100 load balancer per data center. And at that time, we had 6 data centers. So it was a huge amount of money just to be able to route those calls between our application and the various microservices. So definitely, we at that time, in 2010, we chose to go to service mesh. So in order to do that, what we did was simply building small APIs embedded into our applications. We call it CSLB for client-side load balancing. And this API is targeting the various microservices needed by the application. So it's very interesting for us because we have minimum latency. We have the bandwidth which is shared by host, meaning that you don't pay twice the cost of the east-west bandwidth within your data center. You don't need additional machines, for instance. And we choose to simply use a database to update the various targets, because as soon as you start having lots of microservices, of course, you have to get a kind of repository of where to reach a microservice. And this library was implemented at that time for both C# and JVM, which were the major targets in which our applications were written with. So everything went well, and we used this mechanism for quite a long time. It was not a big deal because we were using almost only bare metal servers. So the servers were installed, they were registered, they were running just one kind of microservice or application, and they were running all the time like this. So in the API, we were detecting the failure of the node and so on, but everything was working quite well. The only drawback is in 2015, we wanted to introduce containers. So why do we wanted to introduce container? The first very important thing is it avoids having one machine per feature. The big drawback of installing a complex application on a single machine is it kind of taints the machine, meaning that this machine is not usable for another application later. So using containers would allow us to have just one kind of hardware and just starting a container on this machine, and then, for instance, during the night, fewer people see ads, so we can reuse this machine, for instance, during the night. So it's all about money. It's being able to share CPU and memory and to share machines, so to have less machine in the end. The other interesting stuff was scalability. At that time, just to create a new machine, we spent something like a few hours to install the machine, to install the software on it, to register it in the database, and so on and so on. And of course, the final issue we want to tackle with container was reproducibility. Those instances were running for quite a long time, and the operating system was aging. So people sometimes did connect on the machine was working less well, and so on. And containers offers a way to have clean machine always, and not to have some kind of weird side effect because something has been installed on the machine, for instance. So everybody know this kind of stuff. So those are the pro for containers or virtual machines, but there are also some drawback. The first drawback is as soon as you start having containers, your database is not enough to keep track of all the changes in your infrastructure. Furthermore, we had at that time already lots of machines, something like, I don't know, 20,000 of machines talking to other machines. And the database we used to feed the API, the client-side load balancing API, was showing its limit. Lots of requests per second all the time. It was also very hard to update this value. And a final point is all those instances CSLB API had no idea of the health of a service, meaning that all those applications needed to periodically query their targets to know whether those targets were still healthy. Because of course, when you've got thousands of machines, there are always some machines that are down or unreachable or whatever. The other point was due to low latency and simply legacy, we could not afford to use software-defined network or something like similar. We had to just use bare metal machine, and we could not afford to use virtualization of network. It means that we had to run several containers on the same machine on different ports. And most of the database was not ready for that. It was only one single port for one service. So that was another big issue we had. And of course, having containers means that you can have better granularity, meaning that your instance can be smaller. Being smaller means that you can gradually adjust better your workload instead of having large monolith, large applications running on a single machine. So it means also that you've got far more instances with containers than with bare metal machine when you have just one single application. But of course, all of this make it very hard to discover where your services are. So this move to containers was really showing the limits of all of what we made before, and we needed something new. So at that time, it was we chose to use a Consul, so around 2015. Why? Mostly because he had kind of reasonable service abstractions. It was independent of the network. We are running several ways of running applications. We are running bare metal, of course, Hadoop, Mesos at that time, Kubernetes, cloud. So we are running, and of course, so we had many ways of starting those applications, and Consul offered us a way to describe where those services were, so our service mesh could still work. It also offered a live update of all those changes, including health information. As I told you, it was really hard because the CSLB has to query all the targets. In some of our pools, we've got, for instance, 2,000 instances of a given service, meaning that each of the application targeting this microservice as to just to probe which target it should reach. It's gonna perform 1,000 health check just to get this information. So it's very, very not efficient, especially when you have more and more of those applications. You're spending just your time probing whether the targets are healthy or not. And finally, Consul was built in with fault tolerance as well as multi-DC, and we were in that case. So it was very, very, it was a good choice for the requirements we had at the time. So basically, we plugged Consul everywhere. It's now a full backbone of our company. It's very important. When Consul is done, nothing works. So all this information is now, we've got around 4,000 kind of services. So with more than 200,000 instances. And everything is updated all the time and in all of our data centers. So what we did was we now use Consul to have a unified view of what's within our data centers. So every machine is registered in Consul. Every service, whenever it is running on Kubernetes, on Mesos, on Hadoop, on or just a bare metal service, everything is in Consul. It was very interesting for us because our first big goal was to have a service mesh and to be able as well to use classical edge load balancers. So Consul is not only used for the service mesh, it is also used to automatically provision of our load balancer. So basically, when you are performing a request from the outside of Criteo, you are reaching a load balancer, and this load balancer is provisioned automatically with Consul. It gives us a very strong edge compared to what was previously. Before that, in order to get a new service on the internet, you could spend something like, you had to create several tickets to the network team and so on. And we could spend up to 3 weeks just to get this service up and running. And with Consul, everything is automatically declared and everything is automatically provisioned. It was a very hard way because it was a very hard path to follow because we found several optimization due to the large number of instances we have. But now we've got a full database of everything, and it's provisioning all the communication between all the systems. So what's next? So we are now quite happy with, so we started the move to Consul in 2015. Something like 2 years ago, we had load balancing provisioning. We had all this service mesh relying not on the old database, but on Consul itself. So what could we do better? So the first thing to understand is writing your own service mesh is quite hard. We have to support libraries in 2 languages for the JVM, so Java, Scala, and so on, as well as C#. We have to be consistent, so it's a lot of work just to get the metrics being consistent, to have a kind of similar behavior. It's around 10 kilo lines of code just to get that, and very sensitive code. Those client-side load balancing APIs usually deal with pools with 2,000 instances, for instance, with many clients and so on. And just a few changes in those library might degrade, for instance, quite a lot the performance and so on. So we are, when you are changing something in this code, it's very hard, and you have to be very careful. For those programming, you might know that whenever everybody is using HTTP, it's very hard to get it right. Just if you use Golang, for instance, you can set timeout on the HTTP level, ideal level, on the socket level, on the operating system, and so on and so on. Everything is very complicated. And if you want to have something very, very reliable and with very high performance, it's a huge, huge work, and you're spending quite of time optimizing it. The other point is, while in 2010, everybody found completely normal that nothing is encrypted in the data center, it's not the case anymore. More and more of the traffic on the internet is using TLS, so HTTPS, but people want TLS even within the data center. And whenever you've already programmed TLS validation, and if you have to get it really secure, it's very hard to program as well. And it's the kind of feature we cannot afford to add in those SDK very easily. So that's a big burden. The other point is HTTP 2 is coming, and HTTP 3 as well. So implementing all of this is a huge pain, and it's really hard to get it right. And the other point is we are using this service mesh, and we develop lots of SDK for our application, but whenever we want to use another application for which we don't have the source, for instance, we cannot plug it on the system. We have to use classical load balancer. So that would be interesting if we could use a kind of abstraction in order to replace this service mesh, still have the same performance, and not being forced to modify every applications to run with this model. So what about Rust, Go, Python, and so on? So that was a lot of open questions. So Consul Connect does exactly that. It can work with or without software-defined network. It can work with a sidecar or not. It has a good feature set. It's not too bloated. There's not too many features. It's sidecar agnostic. Intentions allow you with kind of SEL to protect your services from being reached by other systems. And for us, we are working with Consul for quite a long time. We know where the code base, so it was a good candidate. The big downside of that was the sidecar was not working with Windows, and we've got lots of Windows machines still. It also adds some latency, which is exactly what we try to avoid. And it Envoy requires recent glibc, which was an issue for us. So what do we want to do now is simply adding TLS everywhere. So adding HTTPS within our data center. So it's very basic. And while it is basic, we decided not to use Envoy, mostly because Envoy was not supported on the majority of our machines. So, and we wanted to get more confidence with what could Consul Connect provide us. So we decided to implement our own. So it's a kind of weird, I agree. But we had lots of expertise regarding HAProxy. HAProxy is a very old load balancer. And we wanted to run it on our old Linux distribution. And so we started as a project to re-implement Consul Connect with HAProxy. So the project is called HAProxy Consul Connect. It's an open source project. So you can test it. It works with all glibc, of course. It's a subset of Envoy, so meaning that all the features of Consul Connect are not implemented on mostly for now HTTP, but it's simpler. And it is also tested in our large infrastructure. It is developed basically by Criteo, but maintained by HAProxy Tech, the company behind HAProxy. It sends logs on Prometheus metrics, and it's very easy to hack because it's a subset of Consul Connect, basically. Still being completely compatible, of course. So it's simpler. It offers a bit some better performance. I don't have graph, unfortunately, and it's easier to debug than a full Envoy. So less features, and being stable on not having too many features was very important for us, because out of scale, it could advanced feature might cause issues. So what did we have to do to make it work? The first was the standardization of all the features of Connect we wanted to use. To avoid using two exotic settings, you also want to have links to the various metrics of Connect, of your proxies. You want logs, you want dogs, management implementations. So there is a few screenshots of our dashboard of Consul that show a link to Connect metrics, if you see it on this slide. And whenever you are clicking on this, you go to our Grafana graph for the correct service in the correct data center. And here you can see the outgoing traffic of the application. So this is an application. You are seeing the outgoing request per second, and you are also seeing what are the target of this service, meaning that this Connect enabled service will target a service called Prometheus Discovery Graphite Remote Adapter. And you see the specific details of this service, meaning that for all of the outgoing traffic of this service, you can see which service is targeted, how many requests, how many HTTP 200, and so on and so on. So we made lots of standardization with that, and you can have a clear overview of what is going on within your service mesh. You've got the same on the other side, on the service being targeted. And of course, we had also to implement collecting logs for all those new proxies, send those logs to Kibana, and so on. And our current status is we are using it on a few services, just a few dozens, but for months and for critical services, meaning that we are sure that this system is working well in our case. It is working on a few services for now, because what is very hard in those systems is when you have to deal with a large number of instances. So it's around 2,000 queries per second on the largest Consul Connect services, and throughputing around 10 megabits per second of data. So what's next? What we want to do next is deploy the same exact mechanism on larger pools with many more applications using microservices with sidecars. Increase the business criticality of the service being targeted. For now, it's pure infrastructure stuff, but we want to use business services. And we want, of course, to use it for new projects, especially when integrating the client-side load balancing is not possible or easy. From our API point of view, we want something as agnostic as possible, meaning that we start changing our client-side load balancing API, and just by adding a with Connect, you're going to use Connect even on those client-side load balancing APIs. So the benefit would be for this application to use TLS and to use intentions from scratch. And we will start, of course, having very similar API also helps you a lot to do some kind of A/B testing, especially when it's business critical. And finally, all of this seems like we are moving very slowly. We are having a service mesh with sidecar for more than 6 months, but we are moving very slowly. Why? Simply because at large scale, systems such as service mesh are very expensive. They require lots of preparation on existing infrastructure. For instance, Consul Connect doubles the number of services we have. So starting from 4,000, you go to 8,000. It has a significant impact on Consul performance. So we work quite a lot with HashiCorp to improve the performance in all of those cases. And so you have to really take care on a large infrastructure when introducing those sidecar service mesh stuff. And of course, you don't have to, you have to think that all of this includes the complexity of your system. Yes, you've got features. Yeah, you've got standardizations. You've got HTTP2, you've got TLS and so on. But still, when something goes bad, that's one more layer to handle. So thank you very much. This is the end of this presentation. We are doing some blogs. You can have a look, and we are blogging a lot on what we are doing on Consul, our incident, and the various patch we are working with. So thank you very much. I've been a bit too long, and Peter.
Yeah, you're totally fine. I really appreciate your time. We'll open it up for questions real quick just to see if we have any come in. So feel free to enter them into the chat. While we're waiting for that, I did want to ask you, Pierre. So obviously you've been doing this for a long time. What do you kind of wish that you had known from the start that might have helped you along this journey? Like, what kind of roadblock did you hit that you felt like would have been good to know when you were starting this whole transition to service mesh?
Probably the biggest issue we had was doing too many things in-house, which is good for being free of changing of vendors and stuff like that, but still it's a huge amount of work. Not implementing in the first place TLS was probably a mistake, but it was in the era it was too expensive to implement by yourself. And all the big issue with that is you've got lots of tutorials of Hello World tutorials, but the problem with service mesh is doing it on a legacy infrastructure, because legacy gives you money and business. So there's nothing really specific in the history that we could have done things much more differently. But I'm really a big fan of Consul Connect because it's a very simple tool to do that. You've got lots of other implementation. The good thing about it is you can choose to use sidecar or not. You can, and the feature set is small compared to lots of other systems, and simplicity is very important for us because it's really hard at this scale to avoid, I don't know, being too complex.
Perfect, thank you. Okay. Last question I'll say is, like, what are you the most excited for with your service mesh project? Like, what's the next big thing that you are really excited to see kind of come to the reality?
For us, we are kind of weird consumers. Like we are mostly interested with TLS and intentions. What I would be very excited with would be to generate a graph of calls in our data center with intentions, meaning that what is very complex is very large scale systems is defining a path, the path of a failure. Whenever a small microservice is down, you would like to see which service will be impacted. And having intentions allows you, if you are very strict about that, you can build a graph of dependency of services. So you can have an idea about what is going to be the impact of failure. So that's why I am very interested architecture on the architecture side.
Awesome, thank you so much. Okay. I want to be conscious of your time because I know it's a little bit late where you are. So Pierre, thank you so much. Really appreciate you taking the time to talk to us today. Folks, if you have any additional questions for Pierre, we can always drop them to him as outside the chat and reply back with any answers. At this point, I'm going to transition to the next session. So I'm going to introduce Matt Peters, who is a senior solutions engineer on our team. He's going to be walking through the architecture of Consul Service Mesh and kind of how to get started. So Matt, I'm going to turn it over to you.
Hey, Peter, thank you so much. So folks, what I'm going to do today is here I kind of talk about why he went to Service Mesh and the reasons behind that and why I founded this company. What I'm going to do is I'm just going to zoom out real quick and kind of talk about how to get started with Service Mesh. What can I do to download Consul, to get Service Mesh implemented, to implement side proxies, so on and so on.
Hey, Matt, real quick. I think we might be picking up your wrong mic. We're getting a little bit of feedback. I don't know if we're picking up your lapel mic or not.
Okay, just 1 second, folks. Apologize for the delay. A moment. How's this? Is this any better, Peter?
There we go. Perfect. Yep. Yeah, I think we were picking up your wrong mic.
Okay, no worries. Sounds good. So today, with Consul, what we're going to do really is a few things, right? You can download the binary right from our website.
I'm really sorry, Matt. I think we're still picking up your Mac mic instead of your lapel mic.
No worries. So what we're going to do, guys, to pivot here is we're actually just going to go back to some basic PowerPoint slides here. I'm going to share my screen. I'm going to stop this video real quick, and we'll get back to some quick slides here to kind of talk about how we can implement Consul at a high level. So I'm going to start my video here. So you guys should be able to see me. Let me just start sharing my screen real quick, and now we'll pull up the Consul deck and kind of talk about how it works. So once we get started with Consul, and that can be deployed from Terraform. You can download the binary off of our website. If you are talking about Consul in Kubernetes, you can download it via Helm chart. There's multiple ways to actually get Consul on your server or on your laptop to start playing around with it. But when we talk about Connect, the first thing that we're going to want to do is configure a proxy, right? And Pierre kind of talked about sidecar proxies, and sometimes the questions that some people ask is, well, what exactly is a sidecar proxy, and how do I configure that? So a sidecar proxy is basically what does all the communication from one service to another service, right? So if I have a application that needs to talk to my database, the Consul server would have a client that is communicating to a sidecar proxy, and that proxy would be doing all the communication over TLS, right? So the client agent, which is sitting on your virtual machine, on your Kubernetes cluster or a container cluster, et cetera, it would be communicating with that proxy and then allowing or not allowing traffic to communicate to those services. So once that proxy is then configured, then the certificate for an application will get verified upon the communication that's happening between each service, right? So Consul, if the agent cannot find a certificate on a specific service, then Consul can generate a unique private key and send the certificate request to the Consul server to validate that this communication can happen to my other service I'm trying to communicate with. And Pierre kind of talked about this again with regards to some of the next steps, which would be creating intentions for Consul. So an intention is merely a rule to allow or not allow a service to communicate to one another. So a lot of the times when we talk about Consul intentions, the topic of zero trust comes up within our company, or when it comes to with regards to service mesh. Should the web application be allowed to talk to the database application, right? And if you do allow it, how many instances can it talk to? Is it encrypted? Is it non-encrypted, right? All of these things kind of start to form the conversation of service mesh, which is why at HashiCorp we've created the feature in Consul what are called intentions, right? And again, all of this communication is going to happen at the proxy level. So in Consul, what we'll do later on in some of our labs is we'll talk about how and why we define intentions, and what that kind of looks like in the Consul UI, and what it looks like when I have a service that needs to communicate to another service. Now, the wonderful thing about Consul intentions is that the intention itself is based off of the service name. So when we talk about moving to service mesh, which was a lot of what Pierre talked about, it's to save time, it's to save money, and to create a lot of network automation behind the scenes. So if I have 50 instances of my database, imagine how many firewall rules, right, I would have to create to talk to the load balancers, all the IP addresses that I would have to register. Perhaps you have an ITSM tool that you submit a ticket for when this service comes online, right, for 50, 100 instances of my one database. But now with Consul Connect, with the service mesh, I define an intention based off of the name of the service. So it doesn't matter if I have one database, 2, 3, 4, 10, 50, 100. The intention is going to stay the same, and I'm not routing anymore based off of the IP address of the service. It's strictly the name of that service itself, which can allow me to scale up, scale down, whether I'm in on-prem, whether I'm in the cloud, and I don't have that process of registering an IP address or routing an IP address to another service, creating firewall rules, and managing things like IP tables, right? So what I'd like to do next is kind of walk through how this happens, right? What Consul does, it will figure out, where is this application? Where is this database that my web app needs to talk to? It'll then go out and do a TLS handshake with the proxy. The proxy will say, am I allowed to talk to this other application? If I am, great, allow my web app to talk to that database, and the proxies will authenticate themselves via that handshake. So once that connection is established, or once that connection happens, mutual TLS is then established, and then the local agent on the console clients authorize a connection on a locally cached intention. So pivoting forward, what I would like to do is kind of get a little bit more hands-on with how I can do this within Consul. Now, the wonderful thing about how HashiCorp and what we've done lately with some of our technical enablement is we have created labs, right? So up here, we have a service mesh with Consul Lab that is going to allow me to start this track at any point in time, anywhere in the world, to kind of go through why and how a service mesh is needed and some of the subtle nuances it may take to actually get started. So as you'll see here, there's a number of labs to go through. I'm going to walk through this with you folks to kind of, again, go through the ins and outs of how to get started within Consul Connect and the service mesh. So the first thing, we talk about when we hear service mesh or we hear the word is a sidecar, right? I need to define a sidecar proxy in order for my services to communicate to each other. So as I get this lab fired up, what we're going to do, again, is this is the fundamentals of getting that service mesh or getting what we call at HashiCorp Consul Connect started. So again, the first thing I'm going to do is create that sidecar proxy. I'm going to have a service that's already defined, but the proxy itself isn't going to be instantiated yet, which is something that we are going to edit. Once I define that proxy, I'm going to edit Envoy, which is the proxy we're going to use, and then create some intentions to say, hey, allow this service to talk to this other service. So as this lab starts to spin up, again, some of the things to keep in mind here is that all of this can be done on the fly. All of the labs that I'm looking at here can be done in your own convenience, whether it's at home, in the office, so on and so forth. And we should be able to fire this up in just a second. So here we go, right? So what you'll see here is I have a MySQL database instance that does not have a sidecar definition defined yet. So I'm going to take a look here into that service, right? And what you'll see is it's going to connect on port 3306, but I don't have that sidecar defined yet. So I'm going to add the connect stanza in my JSON code here and create that sidecar service. So here we go, simple copy paste command for the sake of time. I'm going to head back to my console UI, but first I'm going to save this file. And I'm sorry, to my console terminal. I'm just going to do a console reload. So what that's going to do is it's going to trigger the stanza that I just updated. So basically, hey, reload that and make sure that that sidecar is in fact defined and created. So I'm going to check that off. I've now created that sidecar in my MySQL service definition, and I'm going to move forward to the next type of the lab, right? So now that we have registered the proxy as a service for Consul on our SQL database, the proxy server of the health should pass, right? So what you'll see here is in my MySQL connection, or excuse me, my MySQL service is I am connected with the proxy, right? The database connection is all set, and that proxy is up and running after I ran that console reload. So we can start the proxy with this no up command here to start the sidecar, and I'm just gonna run that real quick, and this will actually get the sidecar up and running, right? So this should be good to go. And now I've started my sidecar, and now we can do the really fun stuff, which is to get services to start talking to each other. So just to reiterate, I created a stanza in a service, a MySQL service, to define Consul Connect on a certain port and have that sidecar defined. I then started my Envoy sidecar proxy. And now what we need to do is make sure that these services can talk to each other and set up the sidecar so that the upstreams can actually communicate to another service, right? So as this challenge does get set up, here it is, here we go. I'm gonna connect this with Envoy. So what we did, again, is we had an application. We have our app server right now, and it just has an empty sidecar, right, service definition. So I wanna, again, create that sidecar definition for my backend application server, which is a simple WordPress service, and make sure that that has a sidecar defined, and that service can talk to the MySQL service here on port 3306. So much like what I did with my SQL service, I'm going to do the same exact thing for my WordPress service in the service definition. So a simple copy paste here is going to do the trick. And now what you'll see is, again, my WordPress service is here. It is has a destination of MySQL on port 3306. And now I can, since I had that service defined and that upstream configured, what I should do, as always, is make sure to save it and then do a console reload to make sure that that service is in fact, or excuse me, that stanza doesn't get instantiated once console is triggered. So we can check, just doing a simple curl here to make sure that the new listener is in fact following. And there it is. We have the MySQL listener listening on port 3306, and we should be all set with this lab. So again, reiterating, making sure that these services have sidecars set up. We started the Envoy proxy. That proxy was started. I defined an upstream from MySQL to my WordPress service. And then now we're going to use Envoy to connect the application to the database. So let's just check out the definition and how we actually do that. So on line 32 of our code here, which once I open up and can take a look at, you will see that I have connected to a certain IP address, right? So again, the wonderful thing about Consul is that all of our listeners are configured on local hosts, right? So we can just update this to the local host address, which is 1.7.0.0.1, to make sure that connectivity is in fact established. What you'll see is that website is currently not working. My website app isn't working because I have to make sure that these configuration changes do happen in the backend, which is in our simple PHP file here. So again, I'm going to save it. Again, this listener is listening on, now it's listening on localhost since we've configured the proxies themselves. I'm going to head back to Consul,
since I made that configuration change, I'm going to do a simple console reload, as I mentioned. And once I reload my application, I should be all set here now that we have changed the IP address to listen on localhost. And here we are, right? We have that service mesh set up. So the last thing we're going to do is we are going to create a console intention, which is what I had talked about earlier, which is to allow a service to talk to another service. And again, the true north of this is to make sure that the definitions that we are defining within our service mesh can scale to 10, 20, hundreds, maybe even thousands of instances without having to manage things like firewall rules. And at the end of the day, Consul can also be a part of the load balancing, right? The true north of Consul is not only service mesh, but also the ability to do things like health checks, right? Registering service. If instance 1 of database is offline, Consul will then go out. It knows that it's doing health checks every 10 milliseconds, et cetera, whatever you have defined. And it can route around that service, right? Which is essentially what a load balancer does. So making sure that those intentions are in place will allow you to scale these services out to however large your deployment is. So if I want to create an intention, I can do it a number of ways. The great thing about all of our products here at HashiCorp is that we will allow you to do things in the UI, or if you're doing things in a CI/CD workflow, or you're more operational focused, you can do this in the terminal as well. So, in this example, I could go out and make an intention, create an intention here within the UI, right? But in the lab, it's assuming that you're a little bit more operations focused, and you want to do this maybe in a pipeline, in a script when you're setting up Consul, you're deploying something, or if you're just doing it one-off, right? So I'm going to allow my WordPress application to talk to MySQL here, right? So I'm going to do that, and then what you'll see is once I reload this web page, this should be working. And I'll also see in the UI that this is now updated as well. So again, I'm saying allow WordPress service to talk to the MySQL service. And I could have 10, 20, 30, 40, 50,000 of these instances running, but the intention of itself would be the same since we're communicating based off of the name of the service. So I go and reload my web page here, I should be all set, right? Which is exactly what we wanted to do in this lab. So in terms of getting started with service mesh, this is a fantastic lab, and I ran through it a little quickly in the interest of time since we have other speakers. But again, these types of situations and these types of labs, you can put yourself through, and they're hosted publicly on Instruct for any of our engineers who are looking to learn more about Consul to go through. So to head back over to our PowerPoints real quick, what I did want to talk about quickly was the architecture of Consul. Right. So setting this up, again, as I mentioned before, can be done via Terraform. If you're deploying in Kubernetes via Helm chart, you can go to our public facing website and download the binary itself right from HashiCorp.com. But in an enterprise approach, for those of you who are more interested in deploying this at scale, the architecture of Consul is something that is very important to understand when you are in fact deploying it. So Consul itself was engineered with high availability and large scale in mind, right? So you could have multiple clusters spanning out through multiple instances of your cloud regions. You can have a cluster in Amazon talking to a cluster in Google, communicating back to a cluster on-prem, right? Consul can be deployed anywhere, any cloud, any data center, And the services within those data centers can communicate to services outside of their provider or their data center, right? So I could technically have a web application sitting in Amazon, communicate out to a database in Azure or Google or Alibaba or back on-prem, right? It's designed in a way to make sure that your services can communicate anywhere in a true service mesh platform, so that hybrid cloud or multi-cloud is in fact a real thing. So you'll see up here in the PowerPoint that we have a few things defined: a console server, a console client, a proxy, and an application. So I'll start from the latter, which is usually the easy one. An application can be anything that you want, right? It could be a mobile app, it could be a desktop banking application, it could be an Android, it could be anything that your developers or you are working on that your company uses, that has some form of customer-facing or internal-facing usage for the team or for the company that you are working for. And then you see the app communicating to the proxy. When we went over in the lab, the proxy is the one actually doing the communication on behalf of the application. It's the one certifying, hey, can I talk to this other service? It is the key component of the TLS handshake between one service to another, or in this example, app A to app B. Right, that proxy can be Envoy. Consul has its own proxy that you can use out of the box. We use Envoy since it tends to be the standard within the tech world right now, but there are multiple proxies that you can use to make sure that that communication happens between your applications or your services. Above that, you'll see the console client, right? Or sometimes what we refer as the console agent. And the console agent is what's going to be communicating to the console server, right? It sits on your VM or it sits on your Kubernetes cluster to make sure that your services are in fact online, right? So the agent's going to be doing the health checks. Is my application online? Is app, instance 1 through 50 online? If not, report back to the console server and register that application as healthy or unhealthy. Right. So above that, you'll see the console server. And that console server is kind of the brain of the operations, where all of the data is held for your console deployments. Okay. If application A has 50 instances and application B has 40 instances of each other, that is all going to be stored within the console server. It is the hub, it is the brains of the operations, where the client communicates back to if your services are good to go, where the intentions are stored, and if your services are online or offline. So at the highest level, this is how you get started with Consul Connect, right? Deploying the proxy, assuming that you have some form of familiarity with service discovery and service registration. Getting to connect is the day 3 type approach within our crawl, walk, run model here at HashiCorp, and it'll allow you to really scale out the communications between your services or your applications within your data centers or cloud providers. So Peter, I'd like to hand it back over to you. I'm going to stop sharing my screen now, and I know there's some questions that are going on right now in chat, and I haven't had a chance to look quite yet.
All good, Matt. We're going to go ahead and answer those at the end with the panel. We've been dropping in some answers here, but yeah, good engagement. Thank you so much for going over this. I did post the instruct link in the questions that Matt went over. We will be sending that out as well. So for the time being, we know we're about an hour in. So feeling like people are probably starting to need to get up and want to stretch their legs a little bit. So we're going to take just a quick 10-minute break, and then we will go ahead and get back into it for the second half of our presentation. So feel free to get up, stretch for a second, and we will be getting started at about 10:10. So thank you all so much. Okay, everybody. So hopefully everybody enjoyed a nice little seventh inning stretch. You know, baseball back. Figured we got to throw that in there. So at this point, we're going to turn it over to Freddie Vallania. He is a Consul engineer, and he's going to be walking through some of the different gateway functionality that we introduced in Consul 1.8. So Freddie, I'll turn it over to you, and you can go ahead and get started.
Excellent. Thank you so much. Let's see what screen to share. Can you see the presentation view or the speaker notes?
See your presentation. You're good to go.
Okay, awesome. So I'll begin with a quick recap on service meshes for anyone who's just joining us. Here is a simple model showing how two microservices might typically communicate with each other. There's an API service that will discover and dial the IP address of a backend service. In a service mesh, the key change is that a sidecar proxy is deployed alongside every service instance. Services no longer dial each other directly, but rather do so through their proxy over localhost. Now the network's been abstracted away from the API itself, and the proxy can take care of complex routing logic, such as discovering and load balancing between instances of the backend, encrypting outbound communications, retrying on 500 errors, and a lot more. And authorization in Consul between these two services is driven by the feature we call intentions. Sidecar proxies at the destination service authorize or reject inbound connections based on the intentions that reference their identity and the identity of the caller. The important thing to note here is that intentions don't reference IP addresses, only service names, and they apply to all instances of the services that are referenced by the intention. Now, this might be the most common question we get when we speak about Consul service mesh, and I'd like to talk about some of the recent features that we've released to address it. Today, I'm going to talk about two new gateways at the edge of the service mesh that enable traffic to flow in and out, and then I'm going to go through a demo to show them in action. So going back to the service mesh model that I showed earlier, this model is super smooth and awesome when both services can be deployed with sidecar proxies and do not have external dependencies. But what happens when you need to call out to a service where you can't deploy a sidecar? What if our backend needs to make a call to a managed cloud service? Or what if it needs to make a call to services that we manage but haven't deployed a proxy alongside of? There's also the question of how do you allow others to consume workloads inside of a service mesh? If a pioneering team deploys its services onto a mesh, we need to ensure that other teams can still integrate with them. So let's take a step back and answer these both one by one. The first task mostly boils down to enabling traffic from services with sidecar proxies to services without them. New in Consul 1.8 are terminating gateways. Terminating gateways enable your greenfield applications in a service mesh to integrate with existing infrastructure. As with a transition to the cloud, a transition to a service mesh will likely not upgrade all services at the same time. Organizational and technical constraints may keep services from upgrading to a mesh, but applications that do get upgraded will still depend on them. By having these single points of egress from the service mesh, you can easily secure access to external resources from a limited number of gateway nodes. This is particularly valuable when controlling egress from an environment with ephemeral addresses like Kubernetes. With terminating gateways, intentions will authorize connections from ephemeral services to the gateway, and then your firewall has the much simpler task of securing access from known gateway nodes to the final destination. One key feature of terminating gateways is that a single gateway can route to one or multiple services outside the mesh. You will decide what subset of services you want to expose through the gateway. The next task we wanted to solve was accepting traffic from services outside the mesh. Also new in Consul 1.8 are Ingress gateways. Ingress gateways allow inbound access into your service mesh. They can also take advantage of native capabilities of the mesh, like HTTP-based routing. Using Consul's L7 configuration, Ingress gateways can route to a destination service based on attributes like the path and the headers of a request. Ingress gateways are a unified way to ingress into the mesh, regardless of whether you're on Kubernetes or on virtual machines. They allow us to accept traffic, which is then encrypted at the gateway with TLS. They can also listen on a single port or multiple ports and can route to one or multiple services. Once again, you decide what subset of services you want to expose through the gateway and how. Next, I want to show you what it's like to get these up and running. This is the setup that we're going to be working with. You can see that we have a Kubernetes cluster on GCP. The web, API, and cache services are already in our service mesh and communicate with each other through a sidecar proxy. What we want to do is improve the inbound access to web and the outbound access to DB. So now I will switch to the demo. Go away. Great. So this is the UI for our web service, and it actually shows the call graph for its dependencies. We have the web service, which is dialing the API through its proxy, and we can see that because this address right here is the address that web is dialing. So it is reaching the API via localhost 9092, and then the API is reaching the cache via localhost 9093. And for the database, which is not going through a proxy, it's reaching out directly at a hard-coded IP address. We also have the Consul UI, which shows everything is registered. And to start, I'm going to show the configuration that I'm using for Consul on Kubernetes. So I have this GKE data center using the latest version of Consul, the latest supported version of Envoy. We have connect inject enabled, which is going to attach proxies to the pods that you deploy. And we have the UI exposed as a load balancer so that I can access it from my local machine. The first thing we're going to do is enable traffic from the API to the database to go through the mesh. And we are going to do that with a terminating gateway. This shows the additional configuration that we need. There's going to be a new terminating gateway stanza. We're going to enable them, and we're going to leave all the other defaults as they are. Then we're going to upgrade the install, and this is going to take a little moment, and the gateway should appear on the right momentarily after it's been deployed. So after the terminating gateway comes around, another thing that Consul needs to become aware of is the database service that it's going to route to. Here we see the gateway coming up. Its health check's currently failing, but it'll pass soon. So then for the database service, I have this minimal service registration. It places it in this data center that we're in. We define a node and an address for that node and some very basic metadata like the port that that service is going to be reached in and its name. Now we can go ahead and register this directly in the catalog. And the next step that we need to consider is that the database is registered, but we still need to tell the terminating gateway that it needs to route to it. And the way that we handle the configuration for gateways is with something that we call configuration entries. This is an example of a terminating gateways entry. It references the kind. So this is a configuration entry for a terminating gateway. The name, we're just using the default name here, but it could have a different service name if you choose. And this is going to be the names of the services that it routes to. So by associating the name of the gateway to the name of the destination, now anytime that you spin up additional replicas of the gateway or additional replicas of the database, Consul will just take care of that and handle that based on the handle routing based on the name. then we can apply this with Consul config write. Oops. One moment. Over here. And now we see that the database is a linked service to the gateway. But we still haven't updated how the API dials that upstream. So I'm going to do that next. And actually, before that, another thing that we need to handle is once the traffic is going through the mesh, it also gets governed by intentions. So now we're going to need an intention that says the API can talk to the database. I'll add that real quick. And now I'm going to do the update to the API service. So this is what that service definition looks like. The only bits that are really important are down here. So these two annotations are how, so the first one is determining that we need to inject a proxy sidecar into this pod. And the second one determines what upstream services the API is going to call and at what port it's going to reach them. So right now it only has the cache on 9093. And that means that it can access it via localhost 9093. And what we need to do is add the database as an upstream at some port, and then we can update this upstream URI so that the call goes through the proxy and not directly. So here I have a patch that I'm going to apply. It defines the new upstream for the database. This is the port where we're going to dial locally to reach it. And now the upstream has us routing the request through that port. Now we're going to apply that patch. And eventually, this address is going to show the request is going via localhost. So this might take a moment for that new service to come up, and there we go. So now the API is going to reach to the database through its local proxy, which then routes it to the terminating gateway, which then forwards the traffic to the database. So now the next thing I want to show is one of the advantages of having everything having a service and its dependencies be in a service mesh are the benefits to observability. So I have this application hooked up in Honeycomb, and right now this, let's see. Okay, cool. So this is currently just showing a heat map of the latencies of my route span. And what I can do now is look specifically at anything related to this database. So now I can filter queries to where the upstream is this database. I can visualize the P99 distribution. And now I can just have more visibility into different portions of the requests that I'm issuing. And here we can see what a span would look like. This is the portion that called it a database. And now when everything is part of the mesh, we can get that full picture of a request from beginning to end. Now, going back to our mesh, we're going to address that second question, which was, how do we accept traffic? And we're going to do that with an ingress gateway. The ingress gateway configuration is right here. We enable it like the terminating gateway, but we also need to define the port that it's going to be listening on for connections to the backend services. I'm going to apply that. And eventually the ingress gateway will pop up on the right like it did with the terminating gateway. As with the terminating gateway, these are configured via configuration entries. We have the kind ingress gateway, which tells us the kind of gateway this is the configuration for. For the name, our ingress gateway is just going to be registered with a default name. So that's why it's the same. And then for the listener, we're going to spin up a listener on port 8080 for an HTTP service, which is web, and then requests with any host name to that port will be sent to web. In the interest of time, I'm going to go ahead and apply this configuration before the ingress gateway is ready. And we're also going to need an intention that allows the gateway to talk to the web service. So I'll make that. And now I need to grab the address. Cool. So now, instead of reaching the web service through its IP address, we're reaching it through the ingress gateway. And this really opens up a lot of possibilities. What if, now that we can take advantage of Consul's HTTP routing, we can do things like break off a service from this web front end? And that's exactly what I'm going to do. So I have this service definition for an admin service. It's going to be listening on port 9095, and we're going to inject an Envoy sidecar. Now, I'm going to deploy this, and I want to be able to route requests to this admin API whenever I hit the ingress gateway at a specific path. And the way that we can do this is with a service router configuration entry. So we're going to apply it to the service web, and it's going to apply these route rules to incoming HTTP requests. So now, as I mentioned, I want requests that are going to this admin path to route to the admin destination. And for anything that doesn't match that path, I want it to go to the default, which is just web. We can apply that config with that same console config write command. And the result's going to be visible in the UI. So now that I navigate to the web service and the routing tab, I can see that there's two routes here. If I have the admin prefix, we're going to go to the admin service, and everything else is going to go to web. Now, since we have a new admin service, once again, I need to create an intention. And I can now reach the admin service by attaching this pass here. All of it super simple, instantaneous, and we're actually not going to stop here. I mentioned before that an ingress gateway can actually route to multiple services from a single port. There's another way that it can do that, and it's via its configuration entry. Let's say that I want to bypass the web service at the gateway level and go straight to the API. So at the same port 8080, I could then define two services, and we're going to distinguish what service to route to based on the host header. So I'm going to write that out. And now, with the address from here, we're going to test that. 1 second. Great. So I'm going to dial the address of the gateway at this port. And actually, I'll show real quick what this looks like in the UI. Now we have these two upstreams. It's going to show you what host name and port you're going to use when addressing them. And I'm going to dial, and oops, we have a connection error. So as I mentioned before, all of this is governed by intentions. So we need to allow the ingress gateway to speak to the API. Now we have our API response. When we hit this api.fakeservice.org, and if we were to switch that around to dial web, we have web. And that is the end of the demo. Yeah, let me know if you have any questions. Thank you.
Awesome, Freddie. Thank you so much. And we did have some questions, and we're answering them throughout, but we'll probably repeat them on the panel just for visibility for folks. So awesome. So to round us out today, I'm going to have Cody Diarklin join us. He's going to walk through kind of a very advanced topology and talk about like WAN Federation and how to incorporate some of the other HashiCorp tools into into your Consul implementation. So Cody, I'm going to go ahead and turn it over to you.
All right, give me 1 second to get fired up here. We're running a little bit ahead of schedule, which is an unexpected treat. All right, unless anybody yells at me otherwise, I'm going to assume that my screen is sharing successfully. We're going to talk a little bit today around how we're going to connect and lifecycle applications using Consul and Nomad. So those who don't know me, I do this quite often. So I'm sure many of the people watching already know who I am by this point. But if not, my name is Cody Diarklin. I do technical marketing for Consul. I work alongside Peter and Freddie and Matt and all the people who have presented today on how we can tell the stories about how Consul does the things that it does in a really interesting and creative ways. You can find me on Twitter at Cody Diarklin. I respond there much faster than any other medium, so I would highly suggest engaging me on there if you so wish. And then if you want to see kind of some of the stuff I do or some of the code that I push out that's half complete and not always functional, you can find me on GitHub at github.com/CodyD. I always like to start off these presentations with kind of these like bigger kind of questions to get people thinking. And something I want to like talk about and kind of unpack a little bit throughout this is, you know, we talk about a lot of these like things like DevOps and things like secure communications and zero trust networking and all of these like bigger kind of what I would call macro concepts as we build these tools and show these demos. But why do people care? Right? Like, why do people actually care about the service mesh as a concept? And why do people care about security? And why does infrastructure matter? Like, why are people using Terraform? Why are people using Vault? Like, why are these things actually used? It's cool to come on and do a demo and tell a story and have fun with it. But ultimately, at the end of the day, like, why does it actually matter? Why does anybody actually care? And I think if you unpack that a layer down, you find out that it's because applications actually matter, right? Like, people care about security because nobody wants to get that phone call that they leaked, you know, a database out to the public internet, and now they've had this massive data breach. People care about that EC2 instance that lives in AWS because it's hosting an application that actually matters to someone. It might be a low impact to the business, but the person who owns that application probably cares about it in some way. Or it might be something like a medical system, especially with everything going on right now, where it's like critical operations and lives matter. So like thinking about the application at the center of everything we do is super important. And I think what's really interesting about HashiCorp is we have a very kind of unique way of dealing with the way we operationalize applications. And I think that we sometimes get lost in technology and we don't always focus on the fact that ultimately delivering applications, keeping them running, keeping them stable, giving a repeatable process around that, connecting them between complex environments that have very few similarities, and trying to complete some form of like consistency between those environments is actually like a super important thing. So if there's one thing I wanted you to take away from what you're going to see today, we're going to show some really cool tech. We're going to do a really fun demo. We're going to dive into some cool things. But what I want you to take away is this is all about making the application matter and treating the application as truly a first-class citizen in the data center, because really the application is what matters. So we've all seen kind of the HashiCorp story around our products. We have this concept of provision, secure, connect, run, and it's kind of the different stages of where we take applications inside of the enterprise, or even inside of kind of regular developer environments, non-enterprise scenarios. Like, we tend to bucket things into these macro concepts, and these are all part of an overall application journey. We're going to start off talking a little bit about the connect section in Consul. Now, I've gone through and I've done kind of the WAN Federation demo quite a few times. And what WAN Federation is this idea of taking different environments that exist over like a general Consul environment, which might include on-premises data center, public cloud data center, and combining them into kind of one larger cluster, right? So in this case, you can see on screen, I have a very simple depiction of a Consul and Nomad environment running inside of a VMware-based data center, right? So this is vSphere, these are virtual machines, probably in a cluster size of 3 to 5 nodes, just hanging out, waiting to do something. And for a long time, this was good enough, right? We'd use Consul as service discovery. We'd use it to, automate things like Nginx, HA proxy. We'd tap into like F5 and drive automation there. But what we've seen is as customer environments have expanded, as cloud native operating models, DevOps, things like that have taken place, we've seen these different islands start to develop inside of these environments. And now you've got really this customer environment that is represented by this on-premises data center, but also these kind of spokes, if you will, off of the hub of, a presence in AWS, presence in Google, presence in Azure, Kubernetes clusters within that vSphere environment, but maybe operating with complex networks that make it not really the same as the traditional like data center environment is. So these things are operating usually in kind of segmented islands, and the developers popping in, doing work there, and it kind of rolls back to the enterprise as a whole, but they're fairly disconnected. And what people like Peter and Freddie and I and all the people who kind of work on Consul talk a lot about is how do we create consistency between these environments? And how do we take these things that have very little similarities between them and establish a consistent way of communicating those? And in my demos around WAN Federation, that's what we talk about, is how we take these environments, connect them into kind of a central Consul control plane, and apply policies that apply to that entire environment. So when we have an application communicate from a vSphere-based Kubernetes environment, or a Kubernetes cluster living in vSphere, I should say, wanting to talk to something in GCE or GKE, sorry, or GCE for that matter, virtual machine, whether it's Kubernetes cluster, Docker container, how do we create a consistent method of communicating between all of those that is secure by default, and that really treats that application as first class? And we do that using kind of WAN Federation is a functionality that we've added. And what that functionality does is allow us to expose those servers over a single port and allow all communication to take place between those environments. And in this demo, we're going to build on a previous WAN Federation demo I did, where I took a Google Cloud Kubernetes environment, a Amazon EKS environment, vSphere Cube cluster, and joined them all into kind of one massive Consul environment. And then we're going to take traffic and move them between the environments. Kind of as a refresher, getting started with WAN Federation is a very, very easy thing. I try not to use that phrase often because I think that in tech, we like to throw around making it simple or making it easy. Easy is not the same for everybody, right? Like things are tough for different skill levels, and people have talents in different areas. So I try to be very sensitive to not assuming levels of knowledge. That being said, it really is simply a kind of 2 commands to get WAN Federation up and running. We create a secret, and that secret is based on a few components from our Consul environment. So we pull our CA cert out, we pull our key out, we configure our GOS encryption, we add our server config, and we drop that into a secret file. We apply that secret file to our destination cluster, and then we run a Helm install to install. And you can see a sample. This is actually from my environment with a couple of things obviously hidden out. Obviously, really long base 64 encoded cert is not what the actual cert is in my files. I have all of these examples in a Git repo. You'll see a link at the end of this. I dropped it on Twitter, so if anybody wants to see those, you definitely can. But in this example, we apply the secret, and then we do the Helm install. And this will actually bring up Consul on the Cube cluster and join it to our existing Consul environment over that mesh gateway. And part of that server config JSON has that like load balancer address in it. So for external systems, we're going to use the external IP. So in my home lab example, I've natted that out to the edge. So you hit my public IP, there's a port behind it, and then you're able to connect into my mesh gateway, as long as you have the CA cert, CA key, and the gossip encryption key. Again, continuing the refresher, we replicate this across the environment. So I did this for each one of the clouds, and these are the actual config files from each one of those environments. You can see the Federation tag in here is enabled to true. I'm pulling in several of the cert files, setting up a mesh gateway, and we're able to get rolling. And kind of what the end state of this kind of federated Consul environment is is multiple data centers acting somewhat as one, right? My on-prem VM-based environment is my primary, but each one of these kind of spoke-ish style, the Kubernetes clusters is what I would call a spoke, right? So it's the outside edges, and they're all joined over Consul and over those mesh gateways. What does that mean? What that means is we're replicating intention information between them. So the intentions, what I create, are sent out across that environment. We're also allowing upstream communication to be defined. So I can say, hey, front end in Cube on vSphere, you're able to talk to API in EKS, and API in EKS, you're able to talk to database in Google. And I'll unpack that a bit in a second. There's probably a few people on the call who are like, why would you ever do that? I agree. Let me get to that in just a few moments. So once we complete like that federation process, we have this kind of global service mesh established, and we're able now to build traffic patterns between those environments, whether that's splitting, or that's creating failover scenarios, or any of those options. We're secure by default, so we've got intentions applied. They're allowing and disallowing communication. We've got certs in place. We're in a good state for kind of this global service mesh between environments. But as I started off the conversation at the beginning, this is about the application. This is about running, and Consul is, you know, dare I say, useless without applications behind it, right? We need to have applications in there to actually take advantage of service mesh, to take advantage of the key value store if you're in that world, to do service discovery. All is based on having applications leveraging Consul. So now we're going to jump in kind of to the run portion of our presentation here. And again, all of this is going to be demoed in a demo after I finish the slides up. So let's talk about Consul and Nomad. This is a special place in my heart, these two products, because I think that across the entire Hashi stack, the Consul and Nomad have the best better together story. There's a lot of integrations there that really make running applications and then discovering, meshing, and creating communication between those very, very like seamless for people who are getting started. In Consul, you've heard me talk about this a bit so far. We really focus on creating connectivity between inconsistent environments, and that's a phrase that I want to stick with you, because like when you look at, you know, Cube environments, you might have routable pods, you might have non-routable pods, you might have virtual machines that live alongside those in different VPCs. You might have function as a service, Docker containers. All of these are different types of networking. Ultimately, it's all connectivity at the end of the day. Like bytes got to get from one place to another. But they are different environments, and what we focus on is how to create connectivity between those inconsistent environments in a consistent way. We have the ability to apply policy-driven security. Like, for example, we want to apply intentions. We want to control the way traffic flows. We want to do traffic shaping. These are all things that we can apply via policy, and then ultimately those get stored alongside your application as code. And these are things that live maybe in your Git repo and are part of the kind of the identity, if you will, of your application. So when you clone down that repo, you have those service definitions and you have that traffic policy that you expect to be applied. Flipping the page to the Nomad side, Nomad focuses on orchestrating the runtime of the application. There's probably a few people on here who are saying, well, I'm a Kubernetes shop, or I don't really care about Nomad because I'm a Cube. These things exist together. I think of these things as tools on a tool belt, right? And more tools is better than less tools. If all you have is a hammer, everything's a nail. But when you start to bring in like Nomad and Kubernetes, now you have a hammer and a screwdriver or a drill. You have these options for ways to run inside of an environment. And what's really powerful on Nomad is that we can expand beyond just container workloads. We can run Java-based workloads. We can run static execution or static binaries on an environment. We have the ability to dynamically pull down artifacts. So Nomad is really about how we take and orchestrate the running of an application. And that application could be in a number of different platforms. But something that I want to focus on in this presentation is the life cycle of those applications. You know, it's cool to get something up and running. We can all do that probably via bash script or a systemd job, but orchestration is a very different thing. And orchestration to me is how do we control when that application goes down and comes up as a new version? How do we cycle that application out for a new one? How do we control the flow at which that application is released into production? And how do we define that in a repeatable way? So again, like the as code approach. And you'll notice that on that final line of the slide is about like those different as code approaches. You'll see this as kind of an ethos of HashiCorp. We like to do things as code. Ultimately, application runtime should be stored alongside your actual application code, right? So when you have that definition of the Nomad job, or even taking Nomad out of the picture and saying Kubernetes, like that, yeah, that deployment YAML should be stored alongside your application binary, so that when you get to runtime, those artifacts are there for you to consume. So we're a big fan of the as code approach, both from a Consul and a Nomad standpoint. All that being said, I talked a little bit about Lifecycle there. You can think very much in the context of this presentation of Consul handling kind of application networking and the lifecycle of that. And then from the Nomad side, handling the application runtime lifecycle. So there's two concepts there that have always been, at least in my experience inside of the enterprise, very different things, right? We handle application lifecycle. We're switching out binaries, making sure that the new version's running. And then we're going to the network team and saying, hey, I need to switch this in DNS, or I need to add this to the load balancer pool. But when you combine these two tools together, you have this really powerful way to unify lifecycle of the application, and you're handling application networking as a first-class construct, and then the actual runtime of that as a first-class construct. And you do these together in a very fluid way. So back to this diagram again, and I said that I would unpack a little bit about the whole app stretching across an environment thing, which I definitely want to do now. So in this case, we're running our application across these Kubernetes environments. And we have a front end living in the Kube environment on-prem. We have an API living in AWS and a database living in Google. This is horrible architecture, people. Like, I don't want to advocate that this is a good idea by any means. The point of the demo was to show that we can create that connectivity between these environments in a very straightforward way. The point is not to architect it correctly for the demo. What I want you to think more about, though, is the concept of failover, because cloud-based failover is a thing, and the ability to take an application that's running in one location, and if that primary location has an API tier that goes down, I'd rather fail over to a cloud-based location and still be able to connect to my application, albeit with bigger latency or a higher potential of failure just from remote connectivity, than not being able to hit it at all. Likewise, if I'm running with the front end in AWS and the API tier running alongside an AWS, I want that ability to fail over to Google in the event of things like the whole vendor lock-in story, which is a whole nother conversation, or just general migration patterns, or even being able to test an on-prem version and fail that API that lives inside AWS back onto on-prem, or not fail, migrate or temporarily divert traffic, the whole kind of shifting rivers concept. Sending traffic back to on-prem to test a new version and then releasing that new version. So don't take this as gospel of the right architecture to pursue. It's not. Take this as a way to demonstrate connectivity between multiple clouds and the shifting of traffic between those environments. So in those environments, we might have a version 1 of an application, and we likely do. Hopefully you've had a version 1 of an application before. But what happens when we want to lifecycle this out? What happens when version 2 comes along? What happens when we want to test out a new running version of that binary? So we might run that on-prem in this example, and we might actually want to divert traffic to that environment. We might be running a new version of the database, a new migration of the data. We might be running an API that has more enhancements to it, and we want to be able to control the way we switch that traffic over, and we want to lifecycle that in a very intentional and safe way. We talk about this in the concept of progressive delivery. This was a concept kind of that came up with by a guy named James Governor over at Redmonk, who talks a lot about this. And it's the idea of gradually deploying a change as opposed to just a full-blown cutover. And how do we gradually control that switch over, but then also be able to roll back if needed? How do we do things intelligently, like canary deployments, and leverage traffic splitting to gradually move this in a safe way and control our blast radius? Because when you do 100% switch over, your blast radius is quite huge. If you're only sending 3% of your traffic, that's a small amount. You can very quickly identify if there's a problem, back that out back to 100% to the safe location, and reevaluate your situation. So we're very big in Consul land around the idea of progressive delivery, and these ideas that James had kind of laid out. Kind of chase that as something we want to talk a lot about around how we handle life cycling applications. So when it comes to that life cycling concept, there are a couple of key ideas that came out to my brain, and things I wanted to show off in this demo. And that was the idea of partnering traffic splitting with a canary rollout in Nomad. So starting with the application level, you might have that front end.service.consul registered and operating. Maybe that's running in that cube environment, it's running in the virtual machine environment, but you ultimately want to get to a place where the API tier is living inside of Nomad. You'll notice that on the Nomad side, it's api.service.consul still. Again, with the integrations, Nomad has a great way to hook into Consul and automatically register these services. Just like when you add a cube cluster, it automatically registers as well. So we get that automatic dynamic registration of services as they come up. So in this case, we've dropped 2 versions of our front end. Now, just full transparency, we're not doing a front end switch in the demo, but I wanted to show it in the example here. When we drop in these 2 services, they might both be attached to the front end and sending traffic 90% to one, 10% to the other. You can see a sample. Sorry about the size of the text, a lot of stuff to show, not a lot of screen real estate. Sorry about that. But the service definition on the bottom is similar to what Freddie showed when he was working with the Ingress and Terminating Gateways, but it's a service splitter, and we're sending 90% of that traffic to the first front end, but then sending 10% of the traffic down to the second one. So what that means is when Consul intercepts that request to hit the traffic and that network level request to resolve that front end, Consul is saying, hey, 90% go to the original, but I'm going to carve off 10% and send it to this other location. Let's talk about the Nomad side, which is more the actual running side. All right, in the case of like an API, it'll be registered as API, and it might be tagged from Docker as API v1. And we've got this update stanza inside of the actual Nomad job, and I'll show a Nomad job in a few here when we get into the actual presentation or the actual demo side. We have the ability to set the maximum amount of parallel updates. So in this case, I'm running 3, so I only want 1 service to go down at a time. This keeps me up and running, right? So I always have 1 version up, or at least actually 2, because it's only going to cycle out 1 at a time. It's going to want it to be at least healthy for 30 seconds, but if it's not healthy for 9 minutes, it's going to yell at us and say bad things are afoot. So it's got some intelligent checks there to make sure that things are actually working right. You see I've enabled Canary here, and what Canary is going to allow us to do is bring up that second version of the application, but it's going to bring it up in parallel to those other 3. So ultimately, we're going to end up with 4 services running as api.service.consul, and 25% of that traffic is going to be hitting that new version for us automatically. And I can choose to promote that up. And if I do, Nomad will orchestrate the pull down of the previous versions and bringing up the other 2 nodes to get us back to that 3 out of 3 healthy state. Like I said, we'll show this in the actual demo. So in that case, like we've taken kind of the application lifecycle from a network standpoint and shown how we can control the network flow of traffic, but we've also taken the runtime state and shown how we can control which version of that is running and how to lifecycle that out. These are different tools, obviously, different capabilities in kind of the HashiStack tool belt. How do we manage those and how do we control those? And we do that using Terraform. And there's a lot of really powerful ways why Terraform is kind of the right way to do this. It gives us a consistent method of application, right? We define these Terraform manifests, and as we apply these manifests, we're constantly updating the environment, and that is all tracked in our Terraform state. And it's very iteration friendly. So when I go in and I change that from a 90-10 to, I say, oh no, it's broken, it's not working, back to 100-0, or it's looking good, I'm gonna go 50-50. That's all stuff I can iterate on very easily with Terraform. Iterate, Terraform apply, auto approve if you want to do things without any worry about risk, or you do a Terraform plan, see the plan, and then execute it. We can iterate on this very quickly. Something to call out, and I don't use it in this demo, I just ran out of time just to be completely transparent. We released the capability of private networking with Terraform, and this brings up an interesting capability of using Terraform Cloud against environments that typically don't have connectivity to Terraform Cloud. So like an on-prem vSphere environment, isolated environments, we can run that Terraform agent on in that location and have it communicate back to Terraform Cloud. So I could be applying all of these Nomad jobs to an on-prem Nomad cluster using Terraform Cloud, and it will work flawlessly as long as you have connectivity allowed outbound. So it opens up a lot of doors for management, and that applies also to private networks inside of HCS with HashiCorp Consul Service on Azure, or AWS with like HCP as an example. It wouldn't be fair to talk about all the other products and not bring our friends Vault into the picture also. You'll see Vault pop up a little bit in the demo. It's not at the front of the show, but I use Vault in this demo as a method for storing my secrets for the API tier and how it communicates to the database tier. So you'll see that running in a few cube clusters. We have first-class integrations with Kubernetes for Vault, so it runs as the Helm chart, just like Consul does. Very easy to get up and running, very quick to get up and running, and being able to like actually store your secrets in a dynamic and safe way. So I use that in the demos as a kind of method of getting my secrets into pods and automatically injecting those secrets in. So definitely check out the Vault story. What you're going to see here is kind of an end-to-end demo of all of these tools kind of in action. So I'm excited to take you on a spin. All that talking, now we're on to the good stuff. So you can see I have a GitHub repo up here, github.com, coded, Consul app lifecycle. You can go in here and you can actually see the definitions and the actual service splitting and all of the application side stuff that I'm going to work with here. So take a look, hit me on Twitter for questions or in the Q&A chat. Meanwhile, let's get into the good stuff. Switch around here. All right, so first things first, actually what we'll do is we will get into the Consul UI for starters. Just to get us started in a smooth way, I've actually started off with a few of my services in play already. So let me refresh the screen, get us back to baseline. Here we go. This is our virtual machine environment. So this is our primary data center. You see, I don't have really anything running in here. I have a mesh gateway. I have my health check from my NAS UI. I have Nomad up and running, but there's no services actually running here. And if I click through, we can see all of these different environments. So I have Consul running. I have a mesh gateway up and running. I have an Ingress gateway up and running. What I'm going to do real quick is I'm going to switch back into, let's move this around a little bit real quick. There we go. I'm going to switch back into the CLI, and we're going to start to curl our actual, our Ingress gateway, because we're going to get ready to actually deploy some services here. So we're going to go ahead and do we'll switch over to the other window. Do a fun little while loop that I have tested a few times. So we're seeing connection refused. Freddie talked a little bit about intentions. For the sake of simplicity of this demo, I've done an allow all. But the problem that we're having and the reason why we're failing right now is that I have no configs applied for our actual Ingress gateway. So our apps are living inside of these environments. Yeah, I have a database running there. If I go into EKS, I have an API tier running there. If I go into Cube, I have a front end running there. But we're not actually hitting it through the Ingress gateway yet. And we use the Ingress gateway so I could do intelligent traffic policy in front of that. Again, not captured in this demo, but it's something that we would normally do. So what we're going to do now is we're going to apply our first configuration that's going to deploy out our Ingress gateway config. We're going to start seeing resolution for this between the cloud environments. So what we're going to see is that our VM environment is acting as a central control plane. We're applying our Terraform builds to our Terraform manifests to this cluster, and that traffic policy is kind of shipping out to those Cube environments. So the configuration for Ingress gateway, the upstreams are all configured as part of the actual deployment of those applications. But specifically, the Ingress gateway config is what we're going to show here. So I'm going to flip back over. You can see we're still failing. I'm going to switch into my Consul folder. If we go in here, we can see our Consul window. We'll open up that Consul manifest. We can see all of our stuff in here. We can see, as I mentioned before, we have a config entry for the Ingress gateway. We're pointed at front end. We're going to allow any host in. And here's what our splitting configuration is that we're going to define. We define a few other things out in here just as a high level. We set a few things as HTTP-based traffic, which lets us interact from an L7 perspective. We're also setting our provider for Consul and where it's actually going to communicate with. So we'll go ahead and do our Terraform apply, auto approve. John Schulman from the Terraform team would hate me for using that. He likes us to plan those things out and make sure they're going to do what we want, but I like to annoy him a little bit at times. So I'm going to do that anyways. So that's running now. If we switch back over, we can see that the API is healthy, right? We're connecting to it successfully. Getting a little bit of a lag there for a moment while it hangs out for a sec. So if I come in and I cancel this out and I grab this URL here, we should be able, to bring this up in a few moments. There we go. So that's up and running. In a few minutes, it should finish connecting to that back end. and we'll be able to cruise forward. Now, again, if I destroy this, if I go in and I run a Terraform destroy on this, it's going to back out that configuration. So I can easily back this out if I didn't want that configuration in place anymore, right? So I can roll that back out if I want to, and it's going to go back to failing as it was before, right? So we're getting that connection refused. So we'll go ahead and apply that, get that back in configuration. We can see life is healthy again. Our connectivity has been established. If we go in here, we can see I'm running on the Postgres database in a GKE. If I go into the UI and I hit our Cube cluster and the Ingress gateway, we can see the front ends are in place there. Everything is looking good, but we're operating in a state where all of this is operating across these 3 Kubernetes clusters. So let's get started bringing these jobs into Nomad. So if I go into a Nomad environment, we can see I have no jobs currently scheduled in Nomad. Got a couple clients running in this environment, so things are there, but I just have no jobs running. Let's switch back into the command line. We can see I have a number of jobs in here, so that like the API, DB, Jenkins, Nginx. We're specifically concerned about the API, and I'm not going to necessarily decompose this entire job file, but I do want to show a couple of the things that we talked about previously. I'm doing something bad in here and using environment variables for the credentials. I was testing something out, so this one doesn't have the Vault integration set up, but Vault is a native integration in Nomad. I'm using it in the actual Kubernetes files, which I'll show in a few moments as well. But this update stanza is what I want to talk mostly about, as well as this image that's running. So I talked about this in the slide deck. I have that update stanza applied, which is telling Nomad, hey, this job is configured with these parameters around how the application is going to update. So when we issue a new application build to this, follow these processes. And you can see down here we're using beta 2 of our API run. Likewise, if we come in here, if I do do Kubernetes, and then we'll hit just for grins, we will hit the API YAML. This is the representation of the actual deployment that's in GKE right now. You can see I've got that Vault integration running, I've got the Consul integration running, and I'm using just the regular beta tag of that API v2. So the Nomad version is a newer version of that instance. So let's go ahead and do a Terraform, apply, auto approve again. See a bunch of jobs have been created. If we switch back in, we can see running. And these will take a few moments to come up. While these are coming up, we'll switch back into Consul and we'll switch over to our VM-based environment. And we can see those were all automatically registered against Consul. So our API tier is in here. Our data, we have a new version of the database in here. And these are all what we'd consider from that diagram before as kind of the V2 of the instance. So make sure this is still up and good. So we're still good on connectivity there. We're still good on connectivity there. So our app is still working. So now we have the actual app up and running. Let's get back to doing our whole little loop curl action. So version 2 is running. We know that the main version that we were running in GKE is up and running. We know that the API version is running in Nomad now, but we're not hitting any traffic on that. So let's go ahead and make that change. So we'll switch back over to the other window. We'll go back into the console view. And we'll go ahead and edit that console file. And we'll go down to this splitting section. And we'll change this splitting down to 50-50 so that we can be super aggressive with it. So we'll apply that change. And we can see that version 3.0 is picking up now. So we live switched this traffic now. So it's important to think of the architecture of how this is working. This is now going through the Ingress gateway that lives in Cube, hitting a front end that lives there. That front end is talking to the central Consul cluster and saying, hey, where should I send traffic for the API service? And Consul saying, half the time, send it to me and this Nomad cluster over here. Other half, send it to this remote Consul cluster over here. And it's splitting that traffic back and forth between that environment. So 50% of the time going either direction. Now let's go ahead and as Emerald would say, let's kick this up a notch. Let's go in and modify our API job to bring out the new version or the canary version of our service. So we'll back out again. We'll go Nomad. We'll edit that API. I'm just going to grab a random version. I think 7 sounds good. It's a lucky number. Now, before I hit auto approve on this, what I want to do is I want to go back into Nomad. And I'm going to go into that API tier, and we can see how this looks right now. 3 placed, 3 desired, 3 healthy. Things are looking good. Cool things about Nomad, you can come in and see details about those tasks. You can go in and pull files from the location. You can actually start to hit logs for those individual services. So you get a lot of visibility built into the Nomad UI around this. We can also come back up here, and I can just hit API and land right where I was at before. So pretty cool stuff in the Nomad UI as far as interacting with Nomad. If I do a Terraform apply now, it's going to update that job. We get a little 1 changed. Again, if I was doing this in Terraform Cloud, like I talked about before, I'd be committing this code into Git, and Terraform Cloud would be consuming this and running it through the agent automatically. So like these applies would be happening locally. I had it set up last night. I just backed it out because I was doing some other stuff. But this change would be applying with maybe a 30-second delay in front of it as it staged that job and ran in Terraform Cloud. And then you get all of that governance, all of the nice Terraform Cloud features, audit logging, so on and so forth, built right into that. So my strong advice to you is do this in Terraform Cloud for Business. If you want to run this in your lab at home, definitely you can use the local files all you want. But if you're going to do this seriously, look at Terraform Cloud for Business. So look at that. Active deployment. And because I got all speechy, we missed the new service coming up. So if we scroll back up, we can see we were hitting nothing. And then all of a sudden, this one started coming in that jumps from version 3 to version 5. Obviously, version 4 is not great. So we're also getting another field in here just to show some differentiation in the way the API works. So things are looking pretty good from a running standpoint. We're getting resolution back. Things are hitting as we would expect. So let's go ahead and just send all the traffic over to Nomad now. So we'll go in, we'll edit that file. Do a 0 on that. We'll switch this to 100. Again, I could be doing this in VS Code, but I'm already in the terminal, so why not? We'll do that Terraform apply again. And we can actually watch it adjust and send all traffic to both version 3 and version 5. So that's running. It's running. All traffic's sitting there now. And it's splitting traffic between those services. So even though it hit it kind of 5-6 times in a row, it actually over a span of time works out to about 25% because it's moving between each version. So things are looking good. We're not getting any failures. Let's go ahead and promote this up so we can see our canary is healthy. Things are registered successfully. Things are good. Let's hit that promote canary button. And we can actually watch it start to flip that service in our loop curl as it starts to cycle out. So what it's doing now is it's using that parallel flag inside of the update stanza, and it's saying, hey, I can only do this one at a time. So it's bringing down a container, bringing up the new version 7, beta 7 tag that I used before. And it's cycling through that process every time, right? And bringing each pod down, or each Docker instance down. And mind you, these are just VMs that are running inside of my personal environment at home in my lab, right? So these are 3 Nomad VMs that are just running Docker, and Nomad is orchestrating all the things between those Docker. This could very easily be just static binaries on those services as well. Like if I move my API tier out of Python like it is now and put it in Go and ran that as just an executable on those, like it would work the same way. So we can see things are gradually moving over. We've got 2 out of our 3 healthy. It's waiting for the 3rd one to kick over and be healthy now. We're probably seeing a couple of instances, maybe not actually, of it transferring over. And one thing I didn't get to show is if we were in here and looking at API, you would have seen the new services register and gradually like swap out. So you'd see the 4th one come in, so on and so forth as it backed around. So still waiting for that to finish getting fully healthy, but as we can see, like our resolution is fine. We didn't drop any traffic. Like you didn't see any errors in here as like the loops failed. Likewise, if we go back to our application now and hit this, after a few moments, it should refresh. Oh, you know, it's not going to, because I deleted the database last night. So if I came in here and said, what environment am I on? Postgres in Nomad. And hit submit, we can see that saved there. And just to highlight that, what I was actually trying to show here, I'll flip this back over. I wasn't going to do it this way, but we will anyways. We'll flip that traffic back. Send it all the way back to Kubernetes where it once started. And actually, if we go in real quick and I hit refresh, we're still running on Nomad. If I apply this change, it's going to send it back to the other direction. And if I hit refresh, we're back in GKE from whence we came. And we'll wait for that database to finish. There we go. We're all green again. And that ultimately is the entire flow of the demo, right? We could go now in, like we could originally, I could send that traffic to Nomad, update the one in Cube, send it back to Cube afterwards. And I have a very seamless process here for failing that traffic back and forth between the environments. Again, the big things I want everyone to take away from this is that we have the way with like using all of these products together to really handle lifecycle between all of these. You can see I wasn't going in and editing credentials. That stuff was all pulled in from Vault. I was applying this stuff in a central way using Terraform. I'm controlling both the application networking lifecycle and the application runtime lifecycle between Consul and Nomad. And it's a very fluid process. And as someone who likes to write apps, likes to deliver apps, it's a very like seamless experience to move this stuff through the kind of the entire tool chain of deploying out an application and managing it in an environment. So that's the end of the demo. That's the stuff I wanted you to get out of it. I hope you enjoyed it. Peter, you're up to bat.
Awesome. Thanks, Cody. Always love when we get to see the whole stack story coming together and each of the different tools. So I'm going to invite all the panelists to come back on here. We can open it up for questions right now. I got a few that we've kind of been going through that we're going to rehash here, but then also like if there's some additional questions, feel free to drop them into the chat. What I'm going to start off with is Freddie. I think this is a good one, just to kind of get some background. So they asked about Ingress and Terminating Gateways running on Envoy. Could you maybe give us a little bit of background about like how we kind of architected these and how they essentially how they work?
Good question. So yes, someone had asked if these were running Envoy, and yes, they are. All kinds of gateways that we have are instances of Envoy. This is the case for mesh gateways, ingress gateways, and terminating gateways. And what Consul does is that it will take care of pushing all of the configuration to it dynamically. So you can configure like intentions, the upstreams, the like load balancing settings, etc. via Consul, and then we'll make sure that that Envoy proxy gets configured the way you want it to be.
Awesome, thank you. Cody, this one, I think there was a couple different questions on it, but I think it would be good for you to kind of dive into a little bit more. Could you talk a little bit about how Consul Connect interacts with like VM environments and systemd in particular, like running those systemd jobs?
Yeah, thanks for, I forgot that we had committed to answering this one. So yeah, the process ultimately runs kind of the same, right? Envoy has a binary that can be run on VMs as well. So like typically people are used to running Envoy in a Docker container and it lives as a sidecar in Cube or whatever, right? But there is actually an Envoy binary that can be run and we can actually use systemd to turn that on. So like in my environment, I run Envoy as a systemd job alongside, and it's registering services as they come up. So it really works very, very similarly as far as doing a job, starting and having startup as the system comes online. It's a consistent experience to running in like an actual Consul systemd job. I know we have a Mike from engineering or Blake from PM on there. Is there anything you want to add? I know that Blake had a thing he was working on around templating systemd. So happy to have either one of you talk a little bit about your perspectives from more of the engineering or product side. Blake might have disappeared.
I guess just, yeah, briefly from the engineering side. Hi, I'm Mike. I'm an engineering manager on the Consul team. And yeah, we're hoping to hear more about the use cases that customers and users are finding for terminating ingress gateways, and learning about new deployment patterns and any like successes or challenges that you have with them. So like, let us know what works well and let us know what you want to do that you can't yet. And we're happy to figure out how to best incorporate those into our roadmap.
Yeah, and hi, my name is Blake Covarrubias. I'm a product manager on the Consul team. Just back to the System D thing that Cody was talking about. I think, I shared a link in the Q&A answers to an example of creating a System D unit. I think that's one way that you can automate the process of starting and managing the lifecycle of sidecars on Consul. There's obviously other ways that you can start those processes as well, using things like Supervisor D and Upstart. So definitely, please let us know what is of interest to the folks in the community, and we can put together examples in our documentation showing how to run it on various different VM platforms or under different operating systems.
Thanks, Blake. Since I have you off mute, I am going to ask you to dive into this one because I think it was a good question. Talk a little bit about access logs, getting those from our sidecars, so like specifically from Envoy. I think you had a really good answer here that I think the rest of the group would appreciate.
Yeah, so at the moment, the way that Envoy works is when you start it up, it'll log different messages and things to standard out. So if you're running in Kubernetes, you can just do a kubectl logs on the sidecar pod and see output that's coming from there, or in a VM environment, you'll be able to see that under systemd or journalctl, for example. But when you need to do a little more troubleshooting and get some better visibility into the requests that are going in the environment, by default, Envoy's log levels don't provide that amount of detail. So what you can do is you can use Envoy's administrative API to change the logging level, to raise it to a higher level. And Envoy does give you some granularity there, so you can raise the log level for just HTTP traffic or HTTP2 or TCP, kind of whatever you're looking at to get that detail. At the moment, we don't provide a way to save those access logs and to persist them. If you're using, again, systemd or something, you can offload them that way, but we don't have a way natively in Consul to write it to disk. That is a feature request, though, that we're looking at supporting in the near term, so that you would be able to more easily save that data and archive that for whatever purposes.
Awesome. Thanks, Mike. Cody, you had touched on this one, but I think it's a good distinction. Could you tell us a little bit about the differences between like the intentions that we've been talking about and something like annotations in Kubernetes?
Yeah, so like I'll answer this in kind of two ways, both from like a science of cube perspective. Annotations are a way to just add the general, I don't want to call them notes, but like annotations to the running state of like your pods, your deployments. And if you do take a deployment, it's inherited on the pods, so on and so forth. So like these are essentially like usually metadata associated with the things that you're running. Intentions are actually like a security construct. These are identity based allowing or disallowing of traffic between instances. Now, in the case of Consul, there's a little bit of a, I don't want to say a blurred line at all, but like there's a little bit of a distinction because those annotations in Consul actually do things. Like you can have annotations that set metadata versions of the app. So V1 versus V2, similar to what I showed in my demo of like the V1 API, V2 API. You can set those versions in annotations. You can also use annotations to control if it joins a service mesh or not. You can set them to set the default service if it's an HTTP service, or the default port for the service if it runs on like 5,000. So like in the Consul world, those annotations, and even Vault, right? Vault has the Helm chart as well. And like those annotations are how we control the way secrets are distributed from a Vault standpoint as well in the Helm chart. So annotations have a function in that case, and a lot of vendors will use annotations to drive change and functionality to a kube cluster. But you think of those more as like just notes on a pod or notes on a part of a Kubernetes deployment that could be used or could not be used to do a thing, but there's no overlap between intentions and those. Intentions are truly a like identity-based security construct, allowing, disallowing traffic between A, B, 10 A's, 4 B's, so on and so forth.
Awesome. Thanks, Cody. Mike and Freddie, I'll kind of toss this over to both of you because we didn't really touch a ton on ACLs or tokens or anything. Could you maybe just walk through kind of like a high level overview of like how we handle like rotation of tokens and kind of how it plays in Connect, and then also maybe how both the terminating ingress gateways kind of interpret those ACL tokens, and just give like a high level overview about like essentially what role they play in terms of managing traffic and permissions.
So for ingress and terminating gateways, they do need special tokens. So each gateway is going to have to need, so I'll step to terminating gateways actually. They need permissions. Terminating gateways in a way impersonate a service in order to encrypt the inbound connection. So if you have, from my example, an API calling to the database, the terminating gateway is going to present a certificate for the database to the call from the API. In order to do that, it's going to need service write permissions on the services that it routes to. And it's also going to need node read on the services that it routes to. And whenever services are added or removed, there's a few ways that it could be done. You could either update the policies on the token that is attached to the gateway. You could provide a new token to it and restart it. Or there's also roles that could be updated on the gateway. So there's a lot of flexibility in terms of how you could update dynamically, like when you're updating that list of services, also ensuring that the gateway has enough permissions in order to discover the services it's going to route to request the certificates for them if it needs them. And yeah, those would be the big two.
Okay. So I know we had a couple questions on this. Yes, we'll have certain slides and everything from some of our recordings when we post those. I can leave it open for any questions. One thing I do want to launch is we do have a poll that we want to do. So I'll launch that now, or waiting to see if any other questions come in. So feel free and go ahead and enter, like if you'd like to have any follow-up information, or if you'd like to have someone from our sales team reach out or talk to you about any of our products. So we'll go ahead and leave that open. All right, going through. Any other questions from the chat? Let's see if I can pull one from that we answered in our previous queue. I think this is actually a nice one, Blake. If you don't mind touching on this, because I know Matt unfortunately had to drop. Could you talk a little bit about like the agent deploy on Kubernetes and kind of what happens from a high availability and from a scale perspective?
Yeah, sure. So on Kubernetes, the way that Consul is deployed is a couple different ways. So it's important to kind of understand first that in Consul, you have Consul servers, which are managing basically the persistence of the data within the environment and aggregating the service catalog for services that are registered against the client agents that are deployed within the environment. So you'll typically have somewhere between 3 to 5 servers, and then any number of clients, depending on how many physical nodes exist within the data center. In Kubernetes, the servers are deployed as a stateful set. So they have persistent storage attached to them that to keep that data available across pod restarts. And then with the Consul clients, those are deployed as a daemon set. So you'll have one pod on a given physical worker node within Kubernetes. And we rely a lot on Kubernetes to keep those pods highly available. So if they crash, Kubernetes will take care of restarting them, making sure that they're up and running. From the data perspective, I touched on, you have a handful of servers. Consul replicates data across the servers by default. So there is some aspect of high availability there. If you lose a server node, as long as you have enough servers to maintain quorum with the environment, you'll maintain availability of the Consul server cluster and also the integrity of that data. If you lose a node, you're not losing data that's still replicated on the other nodes. And as long as you follow backup policy or a frequent backup policy, you're taking snapshots and storing them off-site. If you have some disaster that takes down the entire data center, then you have a way to recover from that. Mike or Freddie, anything you want to add on that topic?
You covered it well, thank you.
Excellent. All right, we'll do a last call for questions here. Otherwise, I think we can go ahead and wrap it. One of the things I do want to mention, if there were any topics that we didn't cover. I know, for instance, like that tokens question, we gave kind of like a high level overview. Our last virtual day, we actually did a dedicated ACL session. So make sure you go check that out. And make sure you check out HashiCorp.com/resources. You can see a bunch of Consul information. And as always, if you have any additional questions, you can feel free to reach out to us. So let me go ahead and end the poll here. We got everything good to go. And yep. So as I said, this has all been recorded. We're going to work on cutting some of this together and being able to post it on our website with some of the additional resources. I hope everybody learned something today, and have a great day. Thank you all.